showtime. Suppose we have a smooth field phi of x and we'll start in one dimension. So you have a direction x, and for every value of x, a field has a value, and we assume it's a smooth field. And you want to put it on a computer. Now this is a continuous coordinate, meaning there are infinitely many points in any finite interval, so this you cannot put in a computer. So what do? Well, you decide that there is some basic resolution you want. In physics, this is often called lattice constant. And you divide your interval into points whose distance is a. This set of points is called lattice. The basic difference is that they're discrete. So if you open any finite interval in X, there is only a finite number of points, but they're also coordinates. So coordinate can be continuous or discrete, both are okay. And here you only care about the integer. There is a first point, second point, third point, fourth point, all spaced by lattice constant a, nth point. And at each point, you read off the value of the field. So here we are. Here we are. And you discretize it. The coarsest way is an Euler discretization. So you just read it off, write it down. This point is this one. This point is this one. This point is negative. This point is positive. This point is this one. And now what you have is you have a discretized, in the Euler case, a staircase. Remember, you did this when you were learning how to integrate. There's a staircase, and on each interval, or at each point, depends how you want to think about it, the field has a constant value over the interval. So while, here the field varied, you replace it by a bin, a step. And that's your discretized representation of your function, and you refine it as much as you need to get credible answers. You can see that, it's not doing very well around here in representing the function. And now we'll refer to this as a lattice. Now remember, lattice is a coordinate, it's a set of points. State, meaning values of the field, finite number of them at point 1, point 2, and so on to point n. So we have started with a field, and we have ended up with what I'll call lattice state. And what we are doing is we are looking at our continuous function, but we are only measuring it at discrete intervals or lattice points. Now, in principle, the lattice point is any integer. So it's integer. And here it's one dimension, but if there are more dimensions, then there is an integer spacing in every dimension. So it's integers on D. And L is really just a vector. X is also a vector, but L only has integer values. And the lattice state evaluated at the coordinate lattice space system L is a set, not a continuum like a function, but a set of values of the field. And let's take n of them. And sometimes, that's called the configuration. Meaning that if I look at this landscape, it has some kind of figure shape, and I replace it by rice terraces instead of mountains in arbitrary dimension.